So for homework 5, our first part was to create a D flip-flop. So here I've created an entity. I named it my DFF, my D flip-flop. I have 2 inputs, D and clock. And then I have 2 outputs, Q and Q bar, which is Q bar is equivalent to not Q. Then in my architecture, I have a process which my clock is in. And if my clock is at a rising edge, which means if my clock equals 1, then D will follow Q. Otherwise, D won't follow Q, making it the opposite, which is not D, which is equivalent to not Q. So here I've created a test bench. My entity, I named it D flip-flop TB for test bench. And then I end my entity, and then I started architecture for the behavior of this D flip-flop. And here I have component declaration, which my component comes from the entity in my D flip-flop that I showed previously. And here I've created signals. My inputs are set equal to 0, so my 2 inputs are clock and D, which are equal to 0. My outputs are set equal to 0, which means my Q and my Q not is equal to 0. Here I instantiate the under test, which is my D flip-flop. I have a port map, and then in my process, I have a clock if it equals to 0 and a clock if it equals to 1. And then here I have where D equals to 1 and D equals 0. So here I have my wave simulation, and as you can see as I go through, I give a couple case scenarios. Here, clock is at a rising edge 1, and then my D is a 1, so D will follow Q, which is a 1, and the opposite of Q is not Q, which is 0. Here I have my clock is at a rising edge of 1. My D is 0 this time, so D follows Q, and Q is 0. And my Q bar would be the opposite of Q, which is Q naught, which is 1. An example of a falling edge. If my falling edge is my clock is 0, then the circuit won't respond correctly. As you can see, if D is 0, Q will be 1, which it toggles, and my Q bar would be equal to my D. Here's another one where my clock is at a rising edge and D is 1, so here Q will be 1 and my Q bar will be the opposite, which is 0. And it goes through the simulations, as you can see. Here my rising edge is at a 1. D is 0, so D will follow Q. Q is 0. The opposite of Q is not Q, so it'd be 1. And that's my simulation for my D flip-flop.